Hi guys. Is moving with a velocity. If you can multiply mass times velocity, we will get a new quantity. So that we call as momentum. So momentum is nothing but the product of mass and velocity. So momentum SI unit, mass is kg, velocity meter per second. So kg meter per second is the SI unit of momentum. And not only that, momentum is a vector because velocity is a vector. So velocity is having direction. So momentum is also having direction. So it's a vector. So momentum we define as the product of mass times velocity. If object is not moving, so if the velocity is 0, then the object momentum is 0. So we already see that the effects of momentum. Suppose here you can take a truck moving at very low speed can kill a person standing in its path. What's the reason? If the truck, if you can take, so it's moving with less speed, that's 5 meter per second, and it's having huge mass. If you take the mass of truck goes to 2000 kg. So if you can calculate momentum of truck, so momentum of truck we have to product 2000 times 5. So I can get that 10,000 is the momentum. It's a huge amount. Kg meter per second is units. So even though the truck is having low speed, very low speed, but when a person stands, when the truck hits, the person will dies because it's having more momentum. Even though it's having less velocity, but truck mass is more, so therefore the momentum is more. So from that point I can say that momentum increases if mass increases. Okay, let's see one more example. If you can see a bullet which is fired from a gun. So in this case, the bullet is having mass. Let's take mass of bullet very small, if you take as 40 grams. But when it comes to velocity after firing gun, it moves with greater velocity. Let it take the velocity of 250 meter per second. So even though the bullet having small mass, but because of the greater velocity, its momentum is more. So that's the reason the small weight of bullet, the small mass of bullet when fired from gun can kill a person because of large velocity of the bullet. So the impact is just depends upon the mass and the velocity. So this is what we learn about momentum. Now today's class I would like to introduce that change in momentum. So if you define change in momentum, change. So what is the meaning of change? Suppose if I'm having a truck, so let's take this is a truck. So is initially it is moving with a velocity. It's moving with a velocity, initial velocity u. Now the truck is having mass. It's moving with initial velocity u. Can say it is having initial momentum. Therefore, if you can write the initial momentum, so I can write that P initial. What I can get? The product of mass into velocity. I can multiply that mass times velocity. Suppose you apply a force. Force is applied on the truck. Now in this case, the velocity will be changes. Now it's having a velocity, a final velocity, or it's changed its velocity. If I take the velocity as v. Now if I can write that after applying force, change in velocity equal to v. Now in this case, if you can write that momentum, so if you can take that momentum final, so momentum final which equal to mass, because mass do not change, and velocity, here the velocity changed as v. Now this we can take as final momentum after applying force, and this we can take as initial momentum before applying force. Now if you can subtract, I need to calculate change in momentum. For the change in momentum, equal to momentum final minus momentum initial. So if you can subtract final momentum mv minus momentum mu, so this I can write as change in momentum. Yeah, there is a change in momentum. The change in momentum is caused because of we applied force. So this applied force is cause for change in momentum. The person who is applying a force on the car, so that's why that causes change in momentum. Now apart of that change in momentum, I would like to talk one more the same concept, that is that rate of change of momentum. So it's nothing but rate of change of momentum. So rate means in physics, always you remember that rate means with respect to time. Rate means with respect to time. So let's see a case to make you understand. So I am taking a case at here. So now in this case, so he is applying a force on the car. So this is the direction of the force on the car. Now let's take the car mass m equal to capital M. Now initially the car is at rest, but if we can take that it's moving with a velocity. Now if you can take that car mass m and initial velocity as u, therefore I can calculate the initial momentum The initial momentum equal to the product of, I can write that P initial which equal to the product of mass and velocity. Now if you can see, he is applying force on the car. Now the car is accelerating. Now the car is moving, so it is accelerating. Now in this case, if you can take the car mass do not change, so I can take that car mass as m itself only. So if mass is the car mass, capital M, and its velocity changes, I can take that v is its final velocity. Now if we can write that final momentum final is equal to the product of mass and velocity. Now in this case, if you can write that change in momentum equal to initial velocity. So in the initial case, if you can take that as initial momentum mv minus final momentum which equal to mu. So change in momentum, I can write that momentum final minus momentum initial. So if you can subtract that to mv minus mu is equal to m of v minus u. So that is gives us change in momentum. Okay. Now, but when you closely observe, when you can closely observe the thing again, when we closely observe again the whole situation, he is applying force on the car and the car is accelerating. Now the change in momentum is caused because of the applied force. Because of the application of the force, so then only the velocity changes, and the change in momentum is also depends upon how long he applied force. So the force which is applied, if we can play that again, from here the force he can apply to change the car velocity. So let's take that as initially, if we can take it here, it is the timer is showing at here. Let me take at here t equal to 1 second, t equal to 0 second. Now if I take the time at here t equal to 0 second. Now when I can play and he is applying force on the car, and still it is applying. So the force is applied on the car, so that causes the change in the momentum. So if you can take at here the time t equal to 10 seconds, it means he applied force, 10 seconds. So here the amount of time he applied force on the car, that is also we need to consider. That we define as the rate of change of momentum. So if you can write that we known as the rate of change of momentum. So to write the expression for rate of change of momentum, we already know that change in momentum. We know that how to write the change in momentum. So change in momentum is equal to momentum final minus momentum initial. To write the rate of change of momentum, we have to divide with respect to time, that is mv minus mu upon t. So this expression gives the rate of change of momentum. So that is a small difference between the change in momentum and rate of change of momentum. So if you can write that rate of change of momentum, suppose a car mass m, a car mass is equal to m, and initial velocity is equal to v, and final velocity, initial velocity we used to represent as u, and final velocity v, and applied force, a force is applied on the car which is equal to f at a time duration which is equal to t. Now from this above, if you can write that change in momentum, therefore change in momentum is equal to final momentum minus initial momentum. So that is the expression for change in momentum. But we need to write that rate of change of momentum. If we can write the expression for rate of change